All right. Mm-hmm. All right, now, someone tell me, in this equation, I'm missing something. I'm missing what? Oh, what did I just find? I just found slope. What's that? This is my m, because I just found the slope. And I have my x is 2, so what are we missing? Y. So if I have an x and I have a slope, how do I find a y? Slope doesn't matter for this, but... Let us stew in this for a minute. You have an x value. You have an equation. What can you do with your x value? Plug it in. All right, so go back. F of 2 is going to give me what? 2 root 2. This is your y value. So essentially what you have now is a slope that we found in part 1. You plugged in 2 and got out 2 root 2, and that's your y value. Okay, this is a perfect place for don't make yourself go to y equals mx plus b, because I don't care. Go directly to point slope form and leave it. Okay, so I would plug in y minus, what's my y value? 2 root 2 is equal to, what's my slope? 1 over root 2 times x minus 2. Now, this right here is a great place to leave a free response question. In a multiple choice, could they go to y equals? Yes, you still need to be able to distribute and solve for a multiple choice. But you may leave your free response here. And in fact, especially when it's numbers like this can be a lot safer, right? Because how many of us are going to make it through the distributing and the moving everything to one side correctly? Yeah, I'm not trying that on that one. I wouldn't be. Now, on a multiple choice, like I said, you need to be able to distribute and solve. But you can also kind of play matching with decimals sometimes too. We'll talk about that. Okay? Yeah.
Okay,
So when I look at 3 here, it says find the slope of f of x at the given point. Again, if it's one point, it's like instantaneous slope, which always means what? Derivative, slope of the tangent line. Okay? So if this is my f of x, first question, can I find the derivative the way it is right now? No. All right, so what do I have to do to f of x? FOIL, distribute your 3. So I'm going to do a quick foiling and a quick distribution. Oops, that's not a 3. 75 minus 30x plus 3x squared. Okay, now where do I go to find a slope? Once I have my cleaned up f of x, what do? Find the derivative. Take a minute on your own paper, find the derivative, label it properly. F prime of x is equal to. And we'll see what we get in just a second. When I do my derivative here, I will tend to then put stuff in like the correct order, either in the second line of f of x or in the derivative. So I would have found the derivative of 3x squared is 6x. Derivative of negative 30x is negative 30. Derivative of 35 or 75, is nothing. Yeah. So then where'd we go next with this?
and plug it in and 5.
Plug in 5.
And you get 0.
So yeah, f prime of 5 is equal to 6 times 5 minus 30, which gives me a slope of 0. All right, so quick question, because this is going to lead into later. If my derivative gives me a slope is 0, what did my tangent line look like at that place? It's a horizontal tangent line. The slope is equal to 0. Yep. Good.
So
All right.
we don't have to write.
We don't have to write the equation of the line, but we could. In this case, it would just be y equals 0, because I know it's a horizontal line and the y value is 0.
So we would
But we would probably not write the equation of that line.
So what would our final answer be?
This one, our answer is the slope is 0. F prime of 5 is 0, period. Not because that y up there is 0, but because the slope is 0.
Why the next y up there 0?
That was just given to us.
Oh, right.
kind of as an extra piece of information, because if you're not reading the directions carefully, you might think you need both an x and a y for that, but you don't. Okay. Now, what was different in finding the equation of the tangent line? Okay, we already did that in number 2 above. What things do I need in order to write the equation of the tangent line? I need to find the derivative so that I can find the what? Slope. And then I need to plug that in with a point. Was I given a whole point in this one? Yes, I was. So, before we go there, and I'll let you finish it out for me here, let's rewrite g of x together. 2x to the negative 3/4. Good. That's our rewrite. Next, go to g prime of x and see if you can go from there. Now, just a quick point to note. This is what I got for my derivative. Normally, if you are giving me that derivative as your final answer, I'm not okay with you leaving it here. Normally, we take things with the negative exponents and put it on the bottom. In this particular case, is this like my answer to my question? No, it's not. I need to go to the equation of the tangent line. So here's what I'm telling you about this in terms of free response questions and time. When I don't have to clean this up to plug it in correctly, I'm not going to. If I said find the derivative of this and this is your answer, you need to move that negative exponent to the bottom. At this current moment in time, I don't have to do that. I have to do g prime of what number? 1. Now, this is why I'm not going to clean it up. Because when I plug in 1, it does not matter what exponent is on 1. What is the answer? 1 multiplied by that negative 3/2 out front, right? So my slope is that. I don't need to fix that negative exponent to get that answer. And that is like not my final answer either. I have to continue on and go to where?
The equation.
Equation of the tangent line. Equation of the tangent line is in point slope form, so it's going to be y minus what?
So you can just plug in 1 to the original.
Well, do you have to? You've been given your answer.
Oh.
At 1, it's 2. So I just go y minus 2 is equal to, what's my slope? Negative 3/2, x minus 1. Now, this could be a great multiple choice question, because would that one be hard for you to put into y equals form? No. Okay? So on this, first, before we get going, change in number 5 this to a letter H.
We have so many notes.
And I know we do. Today is the day we hit a lot of topics. Those should both be H's. That just got in there because it was f of x is the normal. Okay, so those should both be H's. All right, so we are given h of x. H of x is a quadratic. Okay, so if I want to find h prime of 3, what am I going to do?
Well, first you have to find the derivative.
First, you need to find the derivative, and then you need to do what with that 3?
Plug it in.
Plug it in. All right, so then take a minute there and go ahead and find your derivative in 5, plug it in, and then answer 6 based off of that. All right, so first I'm going to find the derivative, h prime of x. What do we get for our derivative? X minus 2. We all okay with that? Therefore, h prime of 3 is 3 minus 2, or 1. So, 6, we want to know, what does it represent? What does the derivative always represent? Slope of the, at what x value? At 3. That's all you need to know for that. Slope of the tangent line at x equals 3. As soon as it's h prime, slope of the tangent line.
Why would you not say h equals 3?
Well, it's not an h value, it's an x value. You have plugged it in for x. Now, what is 7 asking me to find? The slope. Do I know what h of 6 is right now? I do not. Do I know what h of 0 is right now? I might guess that's going to be, I don't know, h of 6 looks like it is 7. Okay, and h of 0 looks like it is 1. Okay, so you have the graph. If you're not 100% sure, go ahead and plug it in to make sure. But if I was doing h of 6 minus h of 0, we just said at 6, what's my y value? 7. At 0, what's my y value? 1 over 6 minus 0 gives me 6 over 6, or a slope of 1.
I think that's where you got the 7
From the y value right there.
Okay, because I got the same thing, but I just plugged it in. But am I doing that wrong?
Yeah.
Because I plugged it into the x.
Okay, that's also fine, but hang on. You had the option of plugging in 6 and 0 to the original equation above, or if it looks like it crosses exactly there on the graph, then use it. But if you're in any way unsure that it crosses at exactly that number, plug it in, please. What did I just find here? Is this the slope of a tangent line? Like, what did I just get? This is the average rate of change. Anytime you see the actual slope formula, this represents average rate of change from x equals 0 to x equals 6. Or you could say between x equals 0 and x equals 6. So slope of the tangent line, you could also say, if you wanted to, is the instantaneous rate of change. Average rate of change is normal slope. Okay?
Okay, so if we were to draw like a tangent line from where this one's,
That would be a secant line from here to here.
and then that would be our answer.
That one's asking what it represents. The slope of that line should be 1. If I drew that, that would be your answer to 7. Yeah.
7 on it, yeah.
Yeah. The slope of that line would be your answer to 7. Yes. At which point on the graph of h of x will the slope be 0? What x value?
2.
Yep. How do I know that? At the bottom here, we'll have a tangent line that is a horizontal tangent line. Therefore, slope will be 0.
Oh, because we look at the graph.
And that just answered the last part. But what will the tangent line look like? Horizontal line.
Wait, when did you get these?
Average rate of change should always be f of b minus f of a over b minus a. That's essentially our normal slope formula. y2 minus y1, x2 minus x1. Okay? Instantaneous rate of change, what did we say that's the same as? That's the derivative. So we're going to say f prime at, we'll just say, that looks like double prime, hang on. F prime at, I'll say a, whatever it happens to be. Okay? Now, one continuation of this is horizontal tangent lines. Horizontal tangent lines occur only when they have a slope of what? 0. If it has to be a slope of 0, what else has to equal 0? The derivative. F prime of x is equal to 0. So, this is kind of the last set of directions we'll talk about before we jump into using our calculators for this. Okay? You may also be asked, determine the points at which the function has a horizontal tangent line. We did that above, looking at a graph, right? And we could see this is where it changes from negative slopes to positive slopes, right at the bottom, the vertex, therefore it has a horizontal tangent line. What if it's like this one and I don't have a graph, and I don't want to graph it? I just need to find the derivative and find out where the derivative equals what? 0. All right, we know how to find the derivative. Let's do that. F prime of x. What is the derivative of x to the 4th?
4x cubed.
4x cubed. What is the derivative of negative 1/2 x squared? Negative x, yes? We want to know where my derivative, this, is equal to 0. How am I going to solve that? Sure, factoring. Look, factoring came back to us. What can I factor out of that? An x. I'm going to take an x out, and I'm going to be left with what? 4x squared minus 1. Does that keep factoring? Sure does. Look, factoring never goes away. 2x So that means, how many places do I have that we have a horizontal tangent line? We have 3, and those are what x values?
0, and then plus or minus 1 half.
Yay. Good. All right, so then the remainder of our class today is going to be calculator stuff. Okay? Question 1. Find all x values on the interval 0 to 1 at which f of x equals sine of this loveliness times cosine of e to the x has a horizontal tangent line. First off, this is why it's calculator stuff. Do you know how to find the derivative of any of that? No. It's a mess. All right, so we never find those derivatives by hand. Instead, we begin in our calculator by going to y equals and typing in that equation. Okay? Sine of this parentheses, you need to put in between the sine parentheses and the cosine, you're going to need to have a times sign in there. Okay? Times cosine of e to the x. 2 things you need to make sure of while we are doing this. 1 is that you're putting this in your y equals. 2 is that you are in radian mode. All right, so once you have your thing graphed in here, this is where your interval 0 to 1 matters. We want everything on the interval 0 to 1, so you do not want to take your window and make it just 0 to 1, because then you might cut off one at either end. I might go like -1 to 2. So I'm going to go in on my window, and I'm going to change my x min to -1, and I'm going to change my x max to 2. I don't have to change my y mins and maxes, but I'm going to because it looks very small in the middle there. So I might make my y mins and maxes like -3 up to 3. I didn't look at it closely, but I'm just going to make it so it's zoomed in closer. And then I'm going to go to graph. Okay? So now if I'm just kind of sketching what I have on that window, I'll show you what I have here. I have a graph that looks kind of like this. Ish.
Wait, Miss Leonard, what were your x?
Once you have your sketch here, here's what this question's asking us. We want to know all x intervals on x values on that interval at which that has a horizontal tangent line. Okay?
So
What is that?
Or the derivative is...
Where, okay, this is the original, yes?
Yes.
I want to know what? You could find maximums and minimums. That's one way, because that's where it changes from positive to negative, and that's where it's going to have a horizontal tangent line. That's option 1. Option 2 is what I actually prefer. We just said functions have a horizontal tangent line where what?
The derivative equals 0.
Where the derivative equals 0. I don't know why that's not writing correctly. Let's try that again. Where the derivative is equal to 0. Now, can I find that derivative on my own?
No,
I cannot. Good news. Your calculator can do it for you. All right, so everyone go back to your y equals. If you go into y equals, you're going to want to leave that equation in y1, and you're going to want to go down to y2. Okay? In y2, we're going to start off by asking our calculator to find the derivative. That is located under the math menu. Down, mine is number 8. N derivative. Math is right under alpha, and then mine is down at number 8, N derivative.
Oh, whoa, what the?
Oh, and then you just go y1.
Okay, so once you drop that into y2, you need it to say d dx. So you need to put the x in the first one.
Okay.
Inside the parentheses, you need to tell it what it's taking the derivative of, which is, in this case, y1. We all know how to get y1. If you go to alpha f5, hang on, alpha f4, might be lying.
You can do alpha y.
Is it a shortcut? There's a shortcut here. Alpha f4? Yes. It's alpha f4.
Alpha trace?
Yep. It gives you a list of y1 through y9. You want it to find the derivative of y1. So it needs to be d dx, y1, and x equals x.
Wait, why x equals x?
That's just, you can find the numeric derivative at a particular point if you say x equals a certain number.
Okay.
We want it to make an equation for us. Okay, hang on, get rid of that. Okay, so that I did alpha y, there we go. Alpha this one, F4, and you can put y1, and then x equals x. Okay, now, one more thing I want to show you before you graph. If you graph both of them, you're going to see both curves. Yes?
Yeah.
Do we all understand next to y1 and y2 when it has the little black box around the equal sign? That's what it's graphing, yes? So now, if I go back up and hit the left arrow so that that little black equal sign is highlighted, I can hit enter and it will unhighlight y1. Therefore, my calculator will only graph y2.
Wait, sorry, how did
So once we have our derivative in there, I'm asking my calculator to find all zeros between 0 and 1. So like we zoomed out a little bit more than we needed to, right? So I have 1 to the left of 0. Do I need that one? No. I only want to go between, no, don't change that. Just be smart about it. Don't find that one. You know, find the next one. I know that I don't need the one before 0. I only need the one after 0. So I'm going to find the second one first. I'm going to do second calc 0. Left bound, you can scroll down to the left and up to the right. I'm going to get as my first one. And remember, it's best to go 4 decimal places. Okay. I only see 2 between 0 and 1. Accurate?
Yes.
Okay. So you're not solving for a million of these. You're just solving for 2.
0.
Okay. When you have yours, check them against mine.
Where am I supposed to? Now we just have to.
All right. So I had 2 places there where I have x equals 0. I found 2 x-intercepts between 0 and 1. Those are the 2 places that the original function would have a horizontal tangent line. Okay. Now, before we even graph anything in question 2, walk me through the steps on this one. If we want to find the equation of the tangent line, what things do I need to find in order to do that? Derivative.
Gotta plug in
Plug in x to find the what? The slope first. Then, do I have a y value for this x?
No.
No, so I also have to plug in that, but to which equation?
Original.
Original to find my y. Pick something to start with. I don't care what. Now, technically speaking, this is the calculator section, so you can go to 4 decimal places. Could I also just say that the y value for x equals 2 is ln sine of 2? I mean, yeah, I can. But, so again, I want to show you some calculator stuff. The first thing we're going to do is clear out what we have from the last one. So go to your y equals, clear, type in your original equation. ln of sine of x, and close both parentheses. Okay? Now, before we go finding the derivative and all that, let's plug in our x to this to find our y. Okay? Once you have that typed in, I want everyone to quit and go into like your normal calculator screen. Remember how we just found like y1, y2, all of that stuff? We used alpha F4. You're going to do that again right now. Go alpha F4 and put y1 in there. This is called function notation. If I do y1 and then parentheses, I'm trying to plug in what x value? 2. It's going to give me the y value back out.
Oh, well.
Okay?
So you get negative.
Yep. So I did function notation here. I did y1 of 2, and I got out negative point. We're going to go to 4 decimal places here. 0951. So after I have the y value, I'm going to go back to y1.
Oh, you have to type in the y1?
Well, no, we don't have to type in y1. I'm going to go back to y equals, and underneath it, I'm going to do the derivative. So in y2, where do you find the derivative thing?
No.
Math? 8. You want to always say d dx. We want to find the derivative of y1. So you type in your y1. Or get your y1. X equals x.
What did we hit to hit it?
Alpha F4.
Okay? Now, before I graph anything here, okay, do I actually need to look at the graph? The graph of the derivative or the original? Do I need to see a graph on this one? I don't. Okay? I don't need to graph anything. What do I need the derivative for? I need to be able to plug in 2 to the derivative. What did we just do a minute ago that I could use to help me plug in 2 to the derivative? Go do the same function notation, but with y2 this time. So quit your little y equals and do alpha f4. This time we're going to select y2 and plug in 2. Need to use your parentheses. If I do y2 of 2, I personally have gotten negative 0.4577.
And what value is that?
I would have y minus, or plus, excuse me, 0.0951 equals, nope, I lied. Yes, I did. Nope, I'm good. Sorry, see, look at me. I'm mixing my numbers up. The second one is my slope.
So then that's 0, negative 0.
And then x minus 2. Yeah, there's my equation of my tangent line.
So how do we know that was the slope?
3, equation of the tangent line. To that equation, at the point when f prime of x is equal to 2. All right, so let's just unpack that for a minute. Let's pick the part that we do understand. Okay, what part do we understand right now? Okay, we know this is the original, and I want to find the equation of the tangent line. So again, just like we did last problem, what do we need to do? I need a slope. I need an x and a y point, right? And I need to go to point slope form. Here's my issue. Normally when we do this, you have an x. You can plug in your x to find your y. You can plug in your x to find your slope. What do we not have right now? We don't have an x value, right? All right, so that's where this other piece of information comes in. At the point when the derivative is equal to 2. Okay, so if I don't know anything else to do, I have my calculator. Can I graph that?
Yes.
Can I make my calculator find the derivative of that?
Yes.
Let's start there, okay? So in your calculator, clear out what you have. I'm going to put in my y1 e to the x squared minus 3x plus 1. I'm going to immediately then have my calculator find the derivative of that. So I'm going to do that in y2 because right now I want to know where my derivative is equal to 2. I don't want to know where my original is equal to 2, right? I still have to type in my original because I can't find my derivative without it. But, so I'm going to go to y2 and I'm going to type in d dx of y1 x equals x. Okay, again, before I graph, do I need to see y1?
No.
No, I'm going to unhighlight that. And we're actually going to add one additional thing. We want to find whatever all this is at the place where my derivative is equal to 2. Do you remember in pre-calc there were times that I said, here's your equation. We want to know when y is equal to this number.
Yeah.
The only way to find where y is equal to that number is to put it in another part of your calculator. So I'm actually going to have a y3. My y3 is going to be that number 2. So what I'm going to see graphed on my calculator is the derivative and a horizontal line at 2. Now, my zoom is probably wonky here.
Because you need to move it at least at 3.
Right. So at this point, I want to go ahead and do zoom standard before I graph. That's just me. If it's been a mess from before, I'm going to go to zoom standard and just see what I see. Okay? So at this point, my calculator has graphed the derivative, and it has graphed the line y equals 2. And I'm just going to draw you a little sketch of what I see as soon as it shows up. Mine's thinking. Okay? It starts to take a long time to think. Mine looks something like this for my derivative. And then it has the line y equals 2 right here. Is that accurate for what you think you have there?
Yes.
Okay. All right, so let's solve for our intersection here. I'm going to ask my calculator to find the intersection of those two. And my calculator is going to tell me this intersection right here is 2.5821, 2. This is my x value that I'm going to use. Because it said at the point where that. Yes? Okay. Now, this gave me quite a bit of information that I don't even, like if I can interpret it in my head, now I can get further. Okay, we just found x equals 2. So I'm going to come out to the side here, and it's x equals 2.5821. That's the x value that I'm going to proceed with, right? So for my equation of the tangent line, I still need two more things. What do I need?
Your y value
My y value
and your slope.
and my slope. I have one of them right now if I know what I'm talking about.
Your y.
I have my slope. Why is that my slope? It's the derivative. The derivative is equal to 2. What does the derivative represent?
Slope.
Slope of the tangent line. If that's the slope of the tangent line, that's my slope.
So because it gave us a comma 2, that's why?
Well, think about it. If the pink one is my derivative and I plug in 2.5821 to my derivative, what am I going to get back out? 2. That's my slope. Plug in the x to your derivative, you get the slope. Also, the original says f prime of x is equal to 2. F prime of x is slope.
So x and the slope value in this are the same thing.
Nope.
No.
X is that decimal. Slope is the 2.
Oh, okay.
Okay? Now, what's the one more piece of information I need?
A y.
The y. What's the easiest way to find the y?
Y equal, or Y1,
Y1, because that's my original, of what number?
2 point.
Okay, good. Y1 of 2.5821. Now, this is why we go to 4 decimal places, because we need to be accurate to 3. So I've written down 2.5821. If I only wrote down 3 decimal places, my y would not be accurate to 3.
So y equals 0.924.
So my y value is 0.9240 is what I get when I round. Yes?
Yes.
All right, so then from there, equation of the tangent line is easy, right? I've got y minus 0.9240 is equal to my slope of 2, x minus 0.5821. If it says find the x values at which f of x has a horizontal tangent line, if you're given f prime of x is equal to this. So review, we just talked about this on the previous page. The function, the original function, has horizontal tangent lines where what? Where the derivative equals 0. Okay, that happens where f prime of x is equal to 0. What have you been given here? The derivative. Do I need to do y1 is this and find the derivative in my calculator? No. This is the derivative. We want to know where that equation is equal to 0.
So in y1 you only have to type in the derivative.
Exactly.
And then the equals 0.
Good. Okay, so in question 5, we have f of x is equal to that thing on the interval 0 to 3. Find the x-coordinate for the point on the curve at which the tangent line is parallel to the segment joining the end points. Okay? Tangent line means what are we going to have to find?
The derivative.
Derivative. So I am going to have f of x is equal to that, and I'm going to have y2 as my derivative. What's the segment joining the endpoints
That's
thing?
just the slope of connecting the 2 points.
It's an interval, the 0 to 3, and it's the segment that's connecting those two. So when it says parallel to that, that means I need to find the slope of that. How do you find slope?
Y2 minus 1.
Y2 minus y1, x2 minus x1. So what I'm going to do is I'm going to start by typing in f of x into the first equation. Because I'm going to use my function notation everywhere I can. I'm not plugging this in by hand. So I'm going to type in 3x to the 4th minus 4x to the 3rd minus 6x squared minus 2x. While I'm here, I'm going to make it y2 be the derivative of y1.
So math.
Mm-hmm. Ah. wrong button. Alpha y equals, I'm going to do the derivative of y1. Now, before I graph anything, I'm going to handle this parallel to the segment joining the endpoints. The segment joining the endpoints, it's going to be the slope, f of 3 minus f of 0 over 3 minus 0. Since I'm already using my calculator, how do I find the answer to f of 3 and f of 0?
Would you just do y1, 3,
Yes. You're going to do y1 of 3 in your regular calculator part, and you're going to do y1 of 0 in your regular calculator part.
Can you not just do y1 of 3 minus y1 of 0?
Do you know what the y values are? Oh, you could. Yeah. If you want to do it all at once, you can do that and make that the top. So I've got mine as 75 minus 0 over 3, or a slope of 25.